Global 5G Rollout, a comprehensive overview. The global rollout of 5G, the next-generation mobile network, represents a profound shift in telecommunications, with significant implications for economies, industries, and everyday consumers. As of 2024, 5G deployment is advancing rapidly in some regions while facing challenges in others. This rollout is characterized by various phases, strategies, and technologies tailored to local market conditions, infrastructure readiness, regulatory environments, and economic factors. 1. Regional variations in the 5G rollout. Asia-Pacific, South Korea. South Korea was one of the first countries to roll out 5G commercially, launching services in 2019. The nation's aggressive investment in 5G infrastructure, including the deployment of hundreds of thousands of 5G base stations, helped establish it as a leader in the 5G space. By 2023, South Korea had reached near national coverage, and 5G adoption rates remain high, aided by the availability of 5G-compatible devices and government incentives. China. China is pursuing 5G at a monumental scale. The country's state-backed telecom giants, China Mobile, China Telecom, and China Unicom, are leading the charge, deploying millions of base stations across the country. By 2023, China had more than 2 million 5G base stations, and major cities were seeing robust 5G coverage. China's 5G strategy is driven by a combination of national policy, the push for technological leadership, and the desire to stimulate innovation in key sectors like manufacturing and AI. Japan. Japan launched 5G commercially in 2020 with major operators NTT Docomo, KDDI, and SoftBank. The rollout in Japan has been fast in urban areas, although challenges remain in rural regions. Japan's adoption is driven by its emphasis on using 5G for critical applications like autonomous vehicles and smart cities. India. India's 5G rollout has been slower, largely due to regulatory issues, spectrum allocation delays, and infrastructure challenges. However, with a large number of mobile users and a growing digital economy, India is expected to be a significant 5G market by the mid-2020s. The government has taken steps to auction 5G spectrum, and companies like Reliance Jio are moving ahead with 5G testing and trials. North America, United States. The U.S. is home to the world's largest 5G rollout, driven by major players like Verizon, AT&T, and T-Mobile. The U.S. approach has been diverse, with different providers focusing on different types of 5G. T-Mobile has taken the lead with a nationwide 5G rollout using mid-band spectrum, offering a balance of coverage and speed. It has built a large and growing 5G footprint, with a focus on rural and suburban areas. Verizon and AT&T have focused on high-band millimeter wave (mmWave) technology, which provides incredibly fast speeds but has limited range and penetration. This technology is mainly deployed in urban centers. The U.S. also faces challenges related to spectrum allocation, and the regulatory environment is complicated by concerns about Huawei's involvement in the telecom supply chain, leading to security and geopolitical considerations. Canada. Canada is progressing steadily but at a slower pace than its southern neighbor. Major carriers like Rogers, Bell, and TELUS are deploying 5G in cities like Toronto and Vancouver. However, high costs of spectrum, logistical challenges, and the vast geography of the country pose hurdles for widespread coverage. Europe, United Kingdom. The UK is among the early European adopters of 5G, with major cities seeing coverage since 2020. The country's leading telecom operators, including EE, part of BT Group, Vodafone, and Three, have been rolling out 5G services, especially in high-demand urban areas. However, the rollout in rural areas has been slower due to the high cost of infrastructure deployment and regulatory hurdles. Germany. As Europe's largest telecom market, Germany has made significant progress with 5G, particularly in cities like Berlin and Munich. The German government has made efforts to auction spectrum for 5G, but the country faces challenges in implementing 5G in more rural areas. Deutsche Telekom, Vodafone, and Telefonica are key players. France. France has been methodical in its 5G rollout, with auctions for 5G spectrum conducted in 2020 and commercial services launched soon after. Major operators like Orange, SFR, and Bouygues Telecom are competing in the market. However, there are concerns around the environmental and health impacts of 5G, which have slowed regulatory processes in some parts of the country. Middle East and Africa, United Arab Emirates. The UAE is one of the leading countries in the Middle East for 5G adoption. Etisalat and DU, the country's two major operators, have deployed 5G in urban centers and are expanding coverage. The UAE's 5G strategy is driven by its vision of becoming a global. 2. Challenges to global 5G rollout spectrum allocation. The success of 5G relies heavily on the allocation of the right spectrum bands. The low-band spectrum offers good coverage and penetration, but it does not deliver the high speeds that 5G promises. The mid-band spectrum, also called sub-6 GHz, strikes a balance between speed and coverage, while high-band millimeter waves, M-wave, provide ultra-fast speeds but struggle with range and building penetration. Countries have different strategies for allocating these bands, and delays in spectrum auctions or conflicts over spectrum rights can slow down the rollout process. Infrastructure investment. Building the infrastructure necessary to support 5G networks is capital-intensive and involves upgrading or building new base stations, fiber optic backhaul networks, and deploying small cells. The cost of deploying 5G in remote or underserved regions is particularly high, and telecom companies may prioritize urban areas first. Private 5G networks are also emerging as a trend for enterprises, allowing them to create customized, high-performance networks for industrial use cases. Regulatory and policy barriers, government policies, and regulatory frameworks are crucial to the 5G rollout. Governments must balance national security concerns, such as the involvement of companies like Huawei in the supply chain, with the need to ensure rapid deployment and market competition. Regulatory delays in spectrum auctions, competition laws, and licensing issues can slow down the rollout. Some countries, like the US, have security concerns over certain 5G vendors, influencing policy and supply chain choices. Urban versus rural divide. A major challenge for 5G deployment is the disparity in coverage between urban and rural areas. In densely populated cities, telecom operators can quickly roll out 5G networks, while rural areas require significant infrastructure investment. Furthermore, demand for 5G services in rural areas may be lower, leading to slower deployments in these regions. 3. Deployment strategies. Non-standalone (NSA) versus standalone (SA) networks. Early 5G deployments use non-standalone (NSA) architecture, where 5G data is transmitted over a 4G LTE core network. This allows operators to leverage existing 4G infrastructure, speeding up rollout. Standalone SA networks, on the other hand, use a fully 5G core, offering lower latency and higher performance, but requiring more investment. Many countries are transitioning to SA networks as 5G adoption increases. Private 5G networks. Private 5G networks are becoming a key strategy for industries like manufacturing, logistics, and healthcare. These networks provide dedicated, high-performance connections for enterprise applications, enabling Industry 4.0 use cases like smart factories and autonomous vehicles. Telecom operators are increasingly targeting the enterprise market alongside consumer networks. Fourth, key technologies supporting the rollout. Massive MIMO. Massive MIMO, multiple input, multiple output technology, which uses hundreds or thousands of antennas on a base station, is critical to increasing 5G network capacity. This enables networks to support higher data speeds and more simultaneous connections. Small cells. Small cells are compact base stations that improve coverage and capacity in densely populated areas. They are key to expanding 5G coverage, especially in urban environments with high user demand. Edge computing. Edge computing brings data processing closer to the end user, reducing latency and improving performance for applications like virtual reality, VR, autonomous vehicles, and industrial automation. This is especially important for 5G, as it will support high-speed, low-latency applications. 5. Future outlook. By 2025, 5G will cover over 60% of the world's population, with much of this expansion occurring in urban centers and high-demand areas. However, the rollout will remain uneven, with developing regions facing slower adoption due to economic, regulatory, and infrastructure challenges. The transition from 4G to 5G will continue over the next several years, with hybrid 4G/5G networks operating in parallel. Long-term 6G research is already underway, with visions of even faster, more intelligent, and ultra-reliable networks. Conclusion. The global 5G rollout is a transformative process that will reshape industries, economies, and daily life. While leading nations are advancing rapidly, challenges remain in terms of spectrum allocation, infrastructure investment, and regulatory hurdles. As the rollout progresses, 5G is expected to drive innovation, improve connectivity, and pave the way for new technological frontiers like autonomous vehicles, smart cities, and the Internet of Things, IoT. The future of 5G will depend on continued investment, collaboration, and overcoming challenges to ensure widespread